This one is a GMAT hard math question. I'll classify the question as a GMAT 700 level problem solving question in number properties. Concept tested is computing the number of trailing zeros, right? How many trailing zeros will be there after the rightmost non-zero digit in the value of 25 factorial is what the question is. Just quickly going to run you through the process and let's get to the answer, right? The number of trailing zeros, there are few concepts in this. Number of trailing zeros, a trailing zero is a zero, that is the number of zeros that you find after the rightmost non-zero digit. For example, 40500. How many zeros are there in this number? 4 zeros are there in this number. But how many trailing zeros are there? There are 3 trailing zeros in this number. So, number of trailing zeros in a number is equal to this 405000. Is it divisible by 10? Yes, it will be divisible by 10. You will get a quotient 40500 and no remainder. Is it divisible by 100? Yes. Is it divisible by 1000? Yes. 405 is going to be the quotient and there will be no remainder. Is it divisible by 10,000? No. When you divide it by 10,000, you will essentially have 40 as a quotient and 5000 as the remainder. So, what is the highest power of 10 that could divide this number? 1000 was the highest power of 10. That 10 cube was the highest, 3 is the highest power of 10 that could divide this number. The number of trailing zeros is always equal to the highest power of 10 that can divide the number. Highest power of 10 that perfectly divides the number. If you want, you can use this adverb, perfectly divides the number. So, if you have to compute the number of trailing zeros in 25 factorial, what we need to find out is 25 factorial divided by 10 raised to the power of n. Max value that n can take is what we are trying to find out. Now, this divisor 10, if had it been a prime number, we would have worked one way. It is a composite number. So, for composite numbers to find the highest power of a composite number that can divide a factorial, the process is essentially this. We will prime factorize this divisor and write it as a 5 into 2. The powers of both these prime factors are equal. If it is not equal, the step is different. We are not going to worry about it in this particular question. The powers are equal. So, it is sufficient if I find the highest power of 5. The highest power of 5 will give me the highest power of 10 that can divide 25 factorial. Step 3 is computing the highest power of 5 that can divide this number. Take this 25, divide it successively by 5 till you can't divide any further. 25 by 5 is a 5 is a quotient. 5 is further divisible by 5, the quotient is 1. 1 is not divisible by 5. The moment you have reached this point, add all the quotients. So, essentially you get an answer which is equal to 6. So, the highest power of 5 that can divide 25 factorial is a 5 raised to the power of 6. Therefore, the highest power of 10 that can divide a 25 factorial will be a 10 raised to the power of 6. Therefore, the number of trailing zeros in 25 factorial is essentially going to be 6. Right. So, this is one way to arrive at it. The second way is I will just quickly walk you through how else could you have done it if you had not known this method. Right. 25 factorial is a 25 into 24 all the way up to 1. You quickly realize this 25 is a slightly different number in terms of with respect to a 5. You are going to get a trailing zero every time, right, you are going to multiply a number with a 10. I have a 53, multiply it with 10, I will get 1 trailing zero. I have a 53, multiply it with 100, I am going to get 2 trailing zeros, multiplied it once with a 10 and a second time with a 10, 2 trailing zeros. So, every time you can find a 10 in this, you are going to have a trailing zero. A 10 is nothing but a 5 under 2. So, if you find a 5 and you find an even number, you are going to get a trailing zero. The first 5 is when you are in 25 factorial is going to be with a 5. Definitely you will have a 2 to multiply it with it. There are going to be more 2s or more even numbers than multiples of 5. In 25, how many multiples of 5 do we have? 5, 10, 15, 20, 25. Whereas how many multiples of 2 do we have? 2, 4, 4 is actually a 2 square, it's got 2 2s, 6, 8, you have adequate number of multiples of 2. So, you do not have to worry about 2. So, 5 is going to give 1, 5 that you are looking for. So, 5 into 2 will give us a trailing zero. I am just going to write whatever is possible. This is 1 trailing zero number 1. Next, I go to a 10. 10 is already a multiple of 5 and it has got a 0 in it. So, we do not have to worry. So, this is going to give me a second trailing zero. Third is 15. Probably take a 15 into let us say a 4 which is a 60, right. So, that is going to have a trailing zero. That is one more trailing zero. Fourth is a 20, right. Only multiples of 5 are going to contribute to it. 20 into 20 has a trailing zero. I do not need to do anything at all. Now, this one is an interesting number as I said. 25 into, for example, let me do something like 8. 25 into 8 is basically a 200, that gives me 2 trailing zeros. This would have given me a 2 trailing zero any time I multiply it with 2 2s, because 25 is a 5 into 5. You multiply it with an 8, that is going to give us a 2 into 2 into 2. So, this is a trailing 0, this is a trailing 0, and then we have something more, that does not matter, we are looking at only trailing zeros. So, how many trailing zeros did we count? 1, 2, 3, 4, 4 plus 2 is equal to 6. Is that the answer that we got through this method? Yes. So, whether you went with this method, right, revisit this video to understand this method, or you actually computed it by the brute force method, still possible to complete this question in about a minute and a half. The number of trailing zeros in 25 factorial is 6. Choice C is the correct answer to the question.